Welcome back, class. We are now going to talk about the quality of measurements. Last lecture, we talked about the process of measurement, which is assigning to numbers to our phenomena of interest. And now we're going to talk about making sure those numbers really represent what we want them to represent. Because if you remember, our whole study is really only as good as our measurements are. For example, when I was getting my master's, I did my major big paper on empathy, and I was really curious about whether human beings really want to help each other, or if they are motivated by self-interest when they help each other. And that was actually a really tough question to figure out, because a lot of the tests that you give people for empathy are what they call socially desirable tests. And what that means is that people are going to answer like they want you to answer. I mean, they think you want them to answer. For example, if you ask someone, "Are you a nice person?" Of course they're going to say yes. Do you steal? No, not really. Do you lie? Only white lies. So often, people don't really respond the truth in psychological instruments. So we have to figure out ways to ask the question such that they're really responding to the truth. So we saw that a little bit in our lecture on correlational and experimental research. The researchers in that study used the implicit association test, which was kind of a way to trick people into answering like they really feel about the construct. Now and what we're going to talk about now is related to that. We want to know if how we ask the questions is really solid. Is it really catching on to the construct we want? Because remember, we've only got facts, we've only got observations, and they may or may not be good representations of what we really want to know about. So reliability and validity. We're going to talk about first why this is so important, and I talked about it a little bit just now, but I'm going to go over it in more detail. Then we're going to talk about reliability, and then we're going to stop for a minute, and I'm going to give you a little exercise in iterator reliability. And then we're going to come back and talk about validity. So let's get going. Why is this so important? Well, as I said before, the results of this study are only as good as your measures. If your measures are terrible, your study doesn't tell us anything. So what would happen if every time you got on the scale, it gave you a different number? Like some wacky number. One day you get on at your 100 pounds, next day you get it on at your 200 pounds, next day you get on your 20 pounds. Would you trust that scale? No. That's why reliability is important. And that means reliability is consistency. So assuming that your weight is consistent all the time, and we're assuming that some constructs are consistent, so reliability only works for consistent constructs. Reliability means consistency of measure. Every time we measure it, we get the same thing. Reliability is really important, and there's a lot of things that we believe maintain consistency. Mood, self-esteem is assumed to be a consistent construct. Those are the things that we worry. Intelligence. Reliability is really important. It's consistency of measurement. So now what would happen if you tried to measure intelligence by the brain's electrical charge? Great. Actually, I'd like to measure your test performance by the brain's electrical charge. Instead of dealing with the whole test thing and the whole paper thing, I would rather just put a little hat on each one of you and hook it up to a power outlet and measure your brain's electrical charge. I wouldn't even need to worry about tests or anything, and you wouldn't either. I could just give you guys A's or B's or C's, whatever the charge says. that make you happy? No, of course not. Because we want to measure what we say we're going to measure. If we're measuring intelligence, we want to measure intelligence, not electrical charge of the brain. If we're measuring self-esteem, we want to measure self-esteem, not agreeableness. If we want to measure extroverted personality, we want to measure extroverted personality and not bad mood. So I know this sounds really basic, but it's super important, and you can really go astray when you're trying to work with a construct and all you've got is questions. So it's really psychologists and social science and human developmentalists and market researchers, anybody that works with humans spends a lot of time conceptualizing their measures in such a way that they really measure what we want them to measure, and that's validity. So reliability is consistency. Is your measurement consistent over time? Assuming something is stable, you're going to get the same score every time. And validity is correctness, or are we measuring what we believe that we're measuring? Okay, so let's get to the first one, reliability. Reliability is consistency of measurement. You get the same thing every time you measure. If it is 70 degrees outside, you've got a temperature out, every time it's actually 70 degrees, your thermometer says it's 70 degrees. Now, ask you a question. Does this mean that it's right? If you look at your thermometer and it's 70 degrees and you have to run into the house and get your snow boots and a big jacket on, do you think your thermometer's right? No. So one thing you got to know about reliability, it's necessary but not sufficient. So reliability is a very, very good thing, but something can be consistent and not correct. So reliability is just a baseline characteristic. Something can be consistent but not correct. And consistency is important, but consistency plus correctness is what we want from a quality measure. But nonetheless, consistency is our baseline. So there are a couple ways to measure reliability or consistency, and I'm going to mention a few. So the first one is retest reliability, and that's established by administering a test repeatedly. So, for example, I give the same people 2 tests. Now, I'm pretty careful about the tests. They're the exact same difficulty, but they have different questions because I don't want people to remember the questions. So let's say I give you guys a test on the first day of class and the test day of the last day of class. And you can see here, these are everybody's score on the first day of class, and these are everybody's score on the last day of class. And let's say that it's not something that I would assume you to learn. It's not class material. It's just a test of something else that I would assume you to stay stable on over the course of the semester. So we've got test scores 1 and test scores 2. And these arrows represent individual people's scores on the tests. For example, you can see that the person who scored the highest on the test at the beginning of the class scored the 3rd highest at the end of the class. The person who scored the 2nd highest scored the worst. And the person who scored the worst on the first test scored the highest on the last test. So because there was so much change, we can assume that this test has low reliability. It wasn't consistent. People were not consistent in their scores. They were kind of went all over the place. So that's low reliability. Okay, now this is high reliability. And you can see here again, first test, last test, and real consistency of scores. First person stayed first, second person stayed second. We have a little bit of a cross there, but that's not important. That's just normal because we're humans and other things besides knowledge affect our test performance. So that is test-retest reliability. We know that our test is reliable, or we have evidence that our test is reliable because we actually measure the consistency of the test across repeated administrations. So sometimes when you read your articles for the dog project in class, you'll notice that people will report the reliability of the tests. And if they're reporting test-retest reliability, this is exactly how they do it. Now, I just wanted to mention here before we go on, earlier I said that test-retest is often parallel forms, and that just means that the second test is not exactly the same as the first. If it's something they think that people will remember, they change the questions a little bit. And you guys might wonder, those of you that have taken the SAT or the what's it called? It starts with a P. The other one that big test that you guys take to get into college. That part of the reason you pay so much to take that test is the test makers, who are Educational Testing Service in New Jersey, guarantee that their tests have good reliability. So if you'll notice, it's very, very rare for someone to increase their tests a whole lot if they take the getting into college test twice, unless they work very hard with the test prep service. Because the reason is because those tests are designed to be reliable. They're designed to accurately and consistently measure college ability, college aptitude. So that's one reason why the test costs so much, because they have lots and lots of test participants that they test to make sure that these tests are good. Okay, split half reliability. This is something that you also will read about in your articles. Basically the same thing as test-retest reliability, except for this time we don't give the test twice. We give one test that's assumed to be consistent throughout the whole test, and then we compare halves of the test with each other for each person. So it's also called internal consistency or internal reliability, and you'll see that a lot in your articles. And let me give you an example of that. So let's say you've got an 8-question test. So what the researcher would do is take all the questions, the one person's score on all of the odd questions, then one person's score on all the even questions, and compare them with each other. And if those questions were highly correlated, we could say the whole test holds together as one construct. The whole test is reliable. It's consistent within itself. And I actually get an internal consistency statistic for all of your tests. It's important for me to know that I am measuring, or that you guys are consistent within the test, because I know that when I get your scores back and I've got a poor internal consistency statistic from the place in Kuykendall that tests my test, I know that I've got a bad question or two in there that are not related to the other questions. And I look at the test and I change that question if I have to, or I adjust the scores if I have to. Okay, the very last type of reliability we're going to talk about, we've talked about test-retest, we've talked about split half, and now we're going to talk about inter-rater reliability. And they're all the same thing. They're all consistency. They're just different ways of measuring and looking at consistency. And often if it's a really important test or observation, they'll do all three. So inter-rater reliability is established by having multiple observers in agreement. So a very, very common in observation. And you can see the example. We've got two observers here observing one behavior. And the goal is to make sure that they're seeing the same thing. They are consistent in the behavior that they observe and record. Because remember, empirical has to be something that is directly observable and everyone agrees upon. So I had some friends in grad school that did inter-rater reliability, and I like to call the study they did the P study. So they were working for a pediatrician at the UC Davis Medical School, and he was really interested in infant sleep behavior. So what they did is they recruited families for their study, and their hypothesis was that babies would sleep better if they had the scent of the mother near them. So I call this the P study, I think I said that, and the dirty t-shirt study. So what they did is they recruited families from around the neighborhood and the town. They got informed consent from them, which is an ethical requirement, and we'll talk about that in a couple of lectures. And then they gave each mother a t-shirt. So every mother in the study had a t-shirt, and she had to sleep in it for 5 nights straight. So the mother slept in the t-shirt for 5 nights straight. Then the mothers gave the t-shirts to the observers. The observers rolled them up into a little ball and put them in the baby's crib. Now their hypothesis was they had 2 groups of babies, one's with the mother's smelly t-shirt, and one's with a plain brand new t-shirt. And their hypothesis is that the babies with the mother's t-shirt would be calmer and have a better night's sleep than the babies with the smelly t-shirt, or with the non-mother's t-shirt, with the new t-shirt. So we've got 2 variables there. We've got the t-shirt variable, mother smelly or not smelly, and we've got the baby's sleep behavior, whether they move around a lot or not move around a lot. So that first variable is pretty clear. It's actually an ordinal variable. It's got 2 values, smelly or not smelly. And then the second variable, though, and if you think about it, I'm going to pause for a minute, and I want you guys to identify the second variable. What's the outcome? Right. The outcome is the baby's sleep behavior, as defined by how much they move around. So how do you think they measured that? Well, what this particular study did is they put night vision cameras in the baby's rooms. It was not creepy. The parents had learned everything about the study, and they were assured that the tapes would be destroyed after they were rated. So they had night vision cameras in the baby's room. They kept them for 6 to 8 hours. I believe they kept them for 8 hours. And for, I think, 3 or 4 nights. Let's say 3 nights. 8 hours, 3 nights. And then they thanked the participants for the study. And the researchers went on to code the tapes. I mean, you think about it. You've got this videotape of like babies sleeping. How would you quantify? How would you measure baby sleep behavior from those tapes? And nowadays it would be video film. You guys get it though. So what they did is they trained a bunch of undergraduate students, and my friends, Melissa and Erica, were the ones who were in grad school who actually did the training. And they trained undergraduate students to watch the tape. They sped them up 5 times as much, so a 8-hour tape would only take a little bit more than an hour to look at. And at first they all watched the tapes together to decide what was a movement. Like if the baby just wiggled its little baby bottom, was that a movement? They all had to be in agreement. if the baby rolled over. Was that a movement? They all had to be in agreement. So first of all, they got together and they did a coding scheme. Then they watched them separately and counted the behaviors. They counted the baby behaviors on the tape after watching the tapes separately, and then came back again to see if they agreed. So they did this as many times as they could, and if they disagreed, they talked it out. Like, why didn't you think that was a movement? Oh, and they argued it out until they got a good scheme that everyone could agree upon. They watched them separately one more time. They had 3 raters watch each tape. And if they watched it separately and they all agreed using their definition, that's the tape they used as the dependent variable in the study. So that's inter-rater reliability. The short definition is it's having raters look at an observation and agree upon what they're seeing. The long definition is it's a bit of a process, especially if they're trying to quantify something on a ratio scale, because they've got this continuous long variable and they have to agree upon different amounts. But usually people do pretty well. And in the studies, if you're seeing a study with inter-rater reliability, that will be published right along in the methods, with the measurement section and the methods section, because people want to know, did you just guess that the babies were moving? No, we scientifically observed it. So that's inter-rater reliability. So at this point, we know why reliability and validity are so important. We know what reliability is. So I'm going to stop for a second and let you watch 2 films. The first one it's so old, it's kind of hilarious. Even I think it's old, but it's a great example of inter-rater reliability. It's an industrial training film, and they were trying to train market researchers to agree on behavior of housewives. So it's not only ancient, but it's sexist, but it's a good example of inter-rater reliability. So I want you to watch that one, the ancient homemaker video. And after you've watched that and get a good idea of inter-rater reliability, I'm going to post the instructions for this separately so you guys will have an easy way to do it. I'm going to give you a link to another video, and it's one of my favorite scenes from The Princess Bride. And by yourself, I want you to give me an operational observable definition of aggression, and then independently rate by yourself the degree of aggression shown by both sword fighters in the film. So I'll write this out for you. And then instead of a quiz for this particular lecture, I'm going to ask you what your degree of aggression was and how much what your rating of aggression. So I want your definition and your rating, and then I'm going to post it, and we're going to see if we agree as a class. Pretty interesting. Okay, so I'll see you later, and don't worry, I will post what I just said. So I'm going to post one video for you to watch as a sexist ancient example of inter-rater reliability. Then I'm going to post an instruction sheet that tells you what to do with the next video. And then I'll post the next video, which is a scene from The Princess Bride. So I'll see you guys soon.